Binge eating goes cellular. Meet your fat-obsessed microglia. It sounds like a headline from a quirky science tabloid, but it's actually a surprisingly accurate description of what happens in the Alzheimer's brain. Microglia are the brain's immune cells, responsible for keeping neurons safe, clearing out amyloid beta plaques, and maintaining balance in the neural environment. Normally, they're tireless, efficient, and lean, running on free fatty acids to power their constant patrols. But under disease conditions, they start hoarding fat, turning these microscopic janitors into overstuffed, sluggish cells that can barely keep up with their workload. It's the ultimate cellular binge, a tiny cleaning crew drowning in donuts, so to speak, while the mess around them keeps piling up. The reason microglia go from lean and energetic to fat-obsessed has to do with an enzyme called DGAT2. This enzyme is like an overenthusiastic pastry chef in the microglial kitchen, constantly converting free fatty acids into triacylglycerol, the storage form of fat. Under normal circumstances, this process is healthy, providing energy reserves for the cell. But in Alzheimer's, DGAT2 lingers too long, producing more lipid droplets than microglia can handle. The result is a metabolic traffic jam. Microglia packed with fat droplets near plaques clear significantly less amyloid beta than their lean counterparts, and the brain's cleanup operation slows dramatically. Here's the exciting part. This binge-induced paralysis isn't permanent. Researchers at Purdue University found that if DGAT2 is blocked or promoted to degrade faster, microglia can shed the excess fat, regain their mobility, and resume their plaque-clearing duties. Suddenly, the overstuffed janitors spring back to life, reducing inflammation, restoring neuronal health, and reasserting the brain's natural defenses. What looked like a hopeless binge turns out to be entirely reversible, proving that the brain's immune system has remarkable resilience. This discovery is more than just fascinating biology. It represents a fundamentally new way to think about Alzheimer's treatment. For decades, research has focused almost exclusively on plaques themselves, trying to remove them after they accumulate. Now, the attention is shifting to empowering the brain's own cleanup crew. By preventing microglia from becoming fat-obsessed, we can restore their efficiency and allow them to manage plaques naturally. In other words, rather than attacking the mess directly, we give the janitors the energy and tools they need to do their job better. The implications extend beyond Alzheimer's. Fat accumulation in microglia also occurs in normal aging and other neurodegenerative diseases, suggesting that targeting lipid metabolism could broadly support cognitive health. By keeping microglia metabolically fit, lean, and active, the brain can maintain memory, clarity, and resilience for decades. The story becomes one of prevention as much as treatment. If we can stop the binge before it immobilizes the cells, the brain's immune system can keep functioning efficiently and protect neurons long-term. There's also a humorous, relatable angle here. Microglia aren't failing because they're broken. They're simply overwhelmed by too much fat, much like any of us after a weekend binge. Knowing that these cells can recover and return to peak function adds hope and perspective. Alzheimer's doesn't have to be an inevitable decline. The system can be restored, and the brain's tiny janitors can get back to work. So yes, microglia may be fat-obsessed right now, but they are far from defeated. With the right interventions targeting DGAT2 and lipid accumulation, these cells can shed their excess fat, regain mobility, and resume the critical work of maintaining brain health. The binge may have slowed them down, but it can be reversed. It's a story of resilience, recovery, and hope, a reminder that even when cellular janitors overindulge, the system can bounce back, protecting neurons and preserving memory in the process.